I'm sure John will reveal the long and tortured history of his ancient radio. Anything else, John?
Nope, we're good.
Okay, so we'll let John take it away.
Okay, thanks, Keith. Good evening, everyone, and anyone else out there in BC Warren land. Glad you dropped in. We got quite a contrast tonight. Complexity here far beyond what I ever imagined. And, of course, something under the towels here, which is so far back, it's hardly technology. And yet it's going to be really interesting, I hope. I found it so. So it's a story on a really, really old radio, which is why I've called it ancient radio. And it's more of a story. I won't talk about the technology too much because there's not too much to talk about. It's really about what I thought was a remarkable discovery, an interesting letter, technology of the past rediscovered, because I had to look into it and see how does this thing work, whatever it is, and mostly the challenges. Challenges, what challenges? Well, if I see this thing, what am I going to do with it? And one thing leads to another, believe me. So it's going to be more of a story. So it starts here at the horse barn in Kamloops. This is a store that sells, as it says there, feed, tack, posts, ranch supplies. It looks after the ranching community in Kamloops and thereabouts. Nice store, lots of interesting stuff in there, but it's not a radio store. The thing is, my wife owns a horse. She boards it up in Anmore. Great store for her to stop in. I don't have much to do with it, so I just wander around the shop and see what's there. And I found sort of in the back of the store, there's an antique section where the proprietors collected farm implements, tools, furniture. And guess what was in that collection? An old radio. It was pretty beat up. Didn't really know what it was. But I said to the proprietor, hey, can you let me have a look at this thing. It looks interesting. So it was in a wooden box, had a hinged lid on it, a bunch of dials on the front. And when I looked inside, besides looking at the contents of the box in which the radio resided, I found a letter, 7-page handwritten letter. It doesn't show too well there. I have the letters here if everyone wants to look at them. It was to a Mr. Hoadley. Now that's an unusual name. That's all I can remark on. It was an unusual name. But it was written by Mr. Warnock over on the other side there in Oak Bay. He apparently, I guess, is the proprietor. The letterhead on this letter was CW Radio Service Company Limited on Fort Street in Victoria, and dated 1926. So I thought, this is all right. This letter and that address sort of said to me, there's more to this radio than, well, it looks really interesting. I grew up not 2 kilometers from that address. So all of a sudden there's a bond to this piece of radio or whatever it is, and the fellow who serviced it or sold it. And as we'll see, or you can see, he had a lot of correspondence with Mr. Hoadley about how to keep the thing running. So anyways, whatever this thing is, I guess it's about a 1926 vintage. So I read through the letter, all the pages, to see what it's all about. And, it has a diagram here of the front panel. And it has all sorts of instructions in it as to how to run the radio. What they're all for. I opened the lid and I looked inside, and there's rheostats here. There's some tuning dials here. There's some audio jacks, I guess. There's even an on-off switch. And there's a little thing here called a tickler coil. We'll get into that. So I thought, this is getting more interesting by the moment. And what was even better was how to hook it up. This is the power supply. The power supply is batteries. There is no AC. There's no power supply in it. You have to supply external batteries. So what we have over here is 8 big dry cells. I don't know if you remember them. They're about that big around and about that tall. Some of you may remember them, old carbon zincs. So there's a whole pile of those. Then there's 3 45-volt battery packs here. Same thing, dry cells, carbon zinc chemistry. So there's 3 of those stacked up. And then over in the bottom here, there's 2 packs of 4.5-volt dry cells. And then the aerial and the ground connection. So now I know what this thing needs in the way of electricity. I mean, it's quite complicated too, as I found out. So, as I say, getting more interesting here. So I'm looking at this thing and I'm thinking, well, this is quite a find. I can make some judgment calls now as to what this probably is. It's a TRF. It's a tuned radio frequency receiver. Now that's different than, say, a superheterodyne, which was the next generation, which we're probably all familiar with. But the TRF is just that. You tune to the radio frequency, period, and amplify some audio. It's that simple. But we'll see the schematics and the block diagrams of how it works in more detail. It required external batteries. The cabinetry is extremely plain. It's not fancy. It's not furniture. It's crude. And there's hardly any parts in it. Not like today's things. Because of that, it's probably what we would call a farm radio. The farm radio meets these criteria exactly in the 20s because it's made for use on the farm rather than the city where there might have been electrification. Anyways, well, it wasn't going to work. It was dirty and banged up and all the rest of it. But I thought, well, for cosmetic restoration at least, it'd be kind of interesting to do and find out about it. That letter really sold me because it was basically a manual. So, just to go back to the farm radio for a minute, there was no electrification. That's why it ran on batteries. There was no power out there in those years. You have to think in terms of the isolation for those farm folks. I mean, living out in the middle of the prairies, the next neighbor's 5 sections away or whatever it was. You couldn't keep in touch with anything. There was no newspaper delivery. I don't know what the mail was like. So this radio was something of a miracle to those folks. I mean, suddenly they could get in touch with humanity again and know what's going on. So it had to run on batteries. Fancy cabinet work was not required. This has to be cheap. It's a farm, remember. And simplicity of operation is required. But I would have to say it wasn't achieved, and you'll see why. Appendix number 2. I got a bunch of appendices after this for those who are more interested. Always trouble with new technology, eh? Then and now. Trying to get it to work. Nothing changes. Okay, so what am I going to do? It's dirty. But here's the thing. There was nothing that was broken on it. I mean, I looked at the inside. I looked at the outside. Nobody had robbed it for parts. Nobody had broken anything. Everything appeared to be there, even though the front panel was horribly scrubbed with, I don't know what. You'll see in a minute what it looked like. It was awful. The cabinet was plain, but the finish was gone. It was all banged up. But that letter, would you pay $125 for that?
No problem. Oh, yeah.
Right away. No problem. I didn't have to think about that too long. So I bought it and brought it home. Well, there's the front panel. Well, you can see everything's there. That's good. I mean, if you're missing the knobs, what are you going to do? Where are you going to find knobs on a radio that's maybe made in 1925? Or any of the other parts for that matter. But again, by inspection and just sort of knowing what these things were about a bit, there's 2 RF tuning dials here. There's the on-off switch. These are all audio or amplifier controls. There's audio jacks to plug in speakers. You'll notice there's no speaker on this thing. That's an added cost, I guess. And then there's this little knob here, which is the tickler control. Interesting word, tickler control. Anyways, so if you look inside it, this is more interesting. There's the 3 rheostats there. A rheostat is a wire-wound resistor, like a volume control. There's 4 tubes, 1, 2, 3, 4. There's 2 cylindrical things here in little clips, which I don't know what they are. 2 transformers. These look to be like audio transformers. They're not RF transformers. These tuning stages, large variable condensers, right? We got to talk in the language of the day. That's a capacitor for anybody that's not up to date on that. So there's 2 large condensers here with resonant coils. And a whole whack of binding posts across the back here where you hook up all those batteries, the A's and the B's and the C's. If you don't know what that means, it's in Appendix 3, I think. We'll get to it. So that's what it looked like inside. It was dirty, but as you can see, nothing is really broken. As a matter of fact, these tuning units, which includes the dial on the front, if you look in the ARRL book, issue 1, I think it was, it's that green original, well, copy of the original. If you look in the back, and there's a copy in the room here, in the ads, you see these tuning units for sale. Okay. As you said, there's not too many parts in this. This is what it looks like underneath. There's 3 condensers. One of them is a variable. There and there. A switch. And the jacks. And bus bar. This thing is wired with bus bar. It's like probably number 16 tinned. And it's just stiff, bent, soldered. And it just goes all over the place. You know, there's no real layout here, just where everything fits. So, the cabinet. That's the cabinet. Now you can see it's not in terribly good shape. It's not a write-off because the front, the back, the top, the bottom, the sides are all there. It's just really banged up. It's got this hinged up lid on it. And in the back, there's holes drilled in the back panel there to bring the battery wires in and out. I found out this case is called a coffin. People call these things coffin radios at the same time because the radio is inside this wooden box. So here's the challenge. I don't know who made it. I don't have a schematic. I don't have a parts list. I have no idea where you could get a replacement part for if you needed it. I don't even know if it worked. And what about the batteries? Those, you know. So, here come the challenges. Look on the web. So I started off looking for photos, sort of under the antique radio description, to see if I could find anything that looked kind of like what I had. And believe me, there are many antique radios. I guess in the 20s and 30s, still, there's no end of people that were trying to build and sell radios. But eventually I found radios that look very, very much like what I've got, made by a company called Browning Drake. And it was the Browning Drake Corporation in Massachusetts. The next slide will show us a little bit about them. I found out they developed and manufactured these types of radios 1925 through 1930. I also found on other websites that this matched a model DB. I know that sounds backwards to me. I would have thought it was BD, but anyways, it was a DB6 kit that looked very much like what we got here, offered in 1925 for $25. Now, I don't know whether $25 was a lot of money in 1925, but I suspect it was. I suspect it was. The thing is, it was offered as a kit. And I don't think, looking at the construction of this thing, that it was really a kit. I don't think, somebody on a farm would have the expertise or the tools to put this thing together, no disregard, but got better things to do than put together a confounded radio. It probably wasn't like a Heathkit with an instruction book. So who knows? I think it was either assembled by somebody who knew what they're doing, maybe Mr. Warnock, or maybe it came as a finished radio. Don't know. So, I looked into this Browning Drake, whom I'd never heard of before. I had never heard of Browning Drake, but there's their web link if you want to go look at it. It turns out it was closely involved with National Radio Company. But Glenn Browning, one of the partners there, he went on to do other things with the Browning Drake Corporation. But it was interesting that they sold these radios with the two tuning dials, one at each end of the front panel, or with both dials at the left hand of the panel. This on their webpage sort of said to me, this has got to be a Browning Drake. Of interest was the fact that National was the National Radio Company, which made very fine receivers through maybe as early as the 40s, the 50s, and 60s. National radios were well known for being high-performance radios of their day. The Drake is not related to the Drake of the 60s and 70s that made some of the first solid-state transceivers that were popular for a period of time. Anyways, Browning Drake amazingly continued as Browning CB up to 1979, where they got involved in CB radios and other special purpose radios of no particular interest to me. But so, they were not a small player. They were there throughout the years. This is the earliest dated schematic I found, October 24, by Glenn Browning himself. Now, I don't imagine you're really up on reading 1924 schematics. I found it quite interesting because it's quite graphical. You can see these are the coils, drawn as a coil of wire. The transformers are in here as coils. The capacitors are the way they are today. But where's the tubes? Where's the tubes? Well, there's a tube, but instead of standing upright like we're used to, it's over on its side. And there's no circle around it like the envelope. They didn't do that then. You have to look really closely, but there's a filament, a grid, and a plate. And that's how they used to do it back then. But electrically, it looked very much like what I've got here, but it's not identical. So I think I'm on the right track by now. I'm pretty sure I've got this thing nailed as to where it came from. This helped a lot. In this same article, and all this is off the web. I mean, you go poking around, you find all sorts of stuff. This is a picture of the top of the chassis, what their radio looked like, and it's almost the same. It's not identical, but the component placements, the number of tubes, the tuning units, and so on, all much the same. The major difference is there's only two rheostats, or volume controls, whatever you want to call them, and on this one there's three. So I know we're not far off the mark. The thing is, I never did find an exact replica of this radio. So I assumed it was close enough. I got the impression that a lot of people, guys like Browning Drake, were cranking these things out like crazy. They bring out a model, sell a few, had problems, change this, do it again, iterate it, whatever. Anyhow, I need a schematic. If I'm going to do anything with this, I got to have a schematic, and I can't find one exactly, so I'm going to make my own. So this is where the challenges come. I got 4 tubes that I don't know anything about, 2 transformers that I don't know anything about, RF coils, variable condensers, rheostats, power wiring. So I was able to find out all the data on the tubes in an old tube book I got. The transformers I measured with ohmmeters to see that the primaries and secondaries were continuous and of a sensible resistance, which they were. I mean, if one of the primaries or secondaries had gone open, then what would I do? So damn lucky so far. The rheostats didn't work too well, and I fixed them up and so on. Anyhow, every circuit was traced, every connection verified. So now I generated the schematic after I had identified some of the strange parts. Yeah, can't draw a schematic if you don't know what the parts are. That's a condenser or a capacitor. was actually stamped on there, very fine print, 0.001 microfarad. It measured 0.0009 microfarad, so it's spot on. These are the tubes. You probably don't recognize the designations, but they are late teens, early 20s type tubes. They're not exactly plentiful anymore. No. But I could test them. This is one of those unknown cylindrical things which turns out to be a resistor. It's called a grid leak resistor. This other tubular thing was also a resistor called a ballast resistor. And these were the ohmages for grid leaks and ballast resistors of the day, even though they don't look like resistors or condensers or whatever. But those were the major parts to figure out. So we got a schematic drawn up here, and that's what the radio is. It is very close to all the other schematics that I saw for Browning Drake. Just to point out a few things here, we're going to go to a simpler diagram in a minute without dwelling on the complexity, but basically you have an antenna and a tune circuit for the variable condenser. This tube here, they're all triodes, by the way, meaning 3 elements, a filament, a grid, and a plate, would amplify the RF. Transformer coupled it to a second RF amplifier tube. But you'll notice that the output of this tube goes through a coil, which is coupled back to the input coil. And this is the tickler. This is a tickler coil. What it does is, you'll see, this coil actually rotates inside the other coil when you turn the knob on the front of the panel. What it does is it varies the amount of feedback from the output to the input. This is nothing more than a regenerative radio. That stage is regenerating. What that means is, to get the amplification that the radio needs, because these tubes aren't very good, you know, they don't have a lot of gain in them. So to get the gain, you take the output of this amplifier and feed it back to the input, so it amplifies it again. And it goes around and around in a circle, each time gaining in amplitude. And then comes the tricky job of adjusting this tickler coil and the gain controls down here so that the thing doesn't turn into an oscillator. Well, that's just part of the job of tuning it up. Anyways, it also does another thing. It rectifies the amplitude modulated signal, because this is AM radio, through a process of this grid leak circuit, as it's called. And so it detects the audio by rectifying the RF. So this is a very busy stage, very critical stage. Anyways, out of this comes the audio, which is coupled through a earphone jack, through the audio transformer to the first audio amplifier, another triode, through another audio transformer to the output stage, which is the speaker amplifier, which plugs into that jack. And down the bottom are all the voltages that you have to have, and we'll see what that's all about in a minute. So a block diagram, just to simplify it. The first tube here is the RF amplifier on the dial 1 with the tune circuit. It's RF coupled to the second amplifier, this RF amplifier. And there's the feedback circuit, which tickles the input and causes the regeneration. Also the rectification so that you recover the audio, and 2 stages of audio amplification. Those rheostats on the front vary the gain. And the way they vary the gain of the tube is to adjust the filament voltage. So that little filament that's glowing in there red goes a little more red or a little less red, which means the emission goes a little bit up or a little bit down, which effectively varies the gain of the stage. That's not how we do it today with any circuits that I'm aware of. But that's how it is. So you've got 3 gain controls here. You have a tickler control up there, and you've got 2 tuning dials here. So this makes it for a very versatile radio, easy to use. I should point out that the dials on here don't have any markings like 550, 600s, 1100 kilohertz. The dials just go from 0 to 190. That's not related to frequency. They just are calibrated with numbers. Oh well, one thing at a time. So there's the front panel. Tune the RF amplifier tuning was there. This is the detector, regenerative detector. This is the tickler. Those are the three, we'll call them volume controls. Headphone, speaker, power. So it's relatively easy to use. You know, you got to tune this, then you got to tune that, then you tune this back again and tune that back and forth until you think you got it. Then you flip this thing around a bit to stop it from oscillating or squealing, and maybe to increase the level. This one is quite important because if you turn it up too high, the tube doesn't last at all, and it's an old tube. And the other two don't seem to do much at all. But other than that, it's straightforward. So you can see this thing is turning into a lot of fun. Oh yeah, well now comes the bad news. Both the ballast and the grid leak are toast, they're open circuit. Two of the tubes are gone. I have no speaker, no headphones. What are you going to do? So I thought, well, okay, you can fix it up and it makes a nice piece of conversation piece or something. But then, of course, I'm thinking ahead, what if you ever wanted to get this thing working again? Is that ever possible? But, where are you going to get parts? Where are you going to get parts? Well, playthings of past. Where else? Why didn't I think of that? You'd go there, wouldn't you? I mean, if you needed old parts. www.oldradioparts.com. You just go to that website for a laugh. This guy, he has, I don't know how big a warehouse he's got or how many pieces of old stuff he has. It's enormous. It goes on forever. Parts from the 20s, 30s, 40s. I had an old Heathkit tube tester that someone said, you can have it, it doesn't work. I needed the rheostat that adjusts the line voltage level so that you always make the same readings, and of course it's duff. So then where am I going to get that from? Heathkit's long gone. So I sent him an email and said, do you have one of these, sort of, anything at all like that? He writes back, says, yes, I have one of those, exactly, and it's got the Heathkit part number on it. So, what can you say? I mean, there's more pleasure in discovering this stuff than the challenges present. Anyhow, I bought 2 used but tested, guaranteed tubes, $20 each. They're more now. A grid leak resistor, new old stock, $1.40. A ballast resistor in its original packing box with instructions, $2. I bought the very best earphones he had listed for $20. As you'll find out, you can't use 8-ohm earphones of modern times. You have to use special earphones that have a 2,000 ohm coil in them. They had to have resistance because they went right in the plate circuit of the tubes. More on that later. And of course a plug so you can plug in headphones to the radio. So we're doing okay here. So then I took the whole thing apart, just took it to pieces, bagged everything, labeled everything against the schematic, cleaned and tested. I didn't find anything much wrong with anything, actually, other than the parts I just mentioned. So I ordered the parts from, Playthings of Past. Now that faceplate, I wonder what I'm going to do with that. But I painted it with a gloss black lacquer, and it brought the finish up to, I would say, very, very, very close to the original gloss of the plastic that was used. Again, in the appendix, that plastic is something called Priolin. It was a very early thermoplastic developed by DuPont in the late teens. I think this First World War spawned a need for different materials, and thermoplastics were part of that experimentation. So it turned out okay. The cabinet, of course, it had to be sanded and filled and sanded and filled and stained and sanded and, the whole thing. And do all that and then put it all back together again. But I still don't have everything. Again, a web picture, Browning Drake with the national logo of no known font. Can't find it anywhere on the web, anything at all that's even close. And even the designations on the knobs, detector, amplifiers, and the curvy. I mean, how are you going to reproduce that? Even if you could find the font, what would you do? Not my hand. Well, I couldn't even be certain that these designations were on the front panel. There's no way to know. I could never find the exact radio. I could never find a photo. The front panel was scrubbed, destroyed. So what was on there? But having seen this, these knobs are the same knobs. I said, oh, heck, this is what I'm going to do anyways. That's what I'm going to do. Good enough, close enough. I also found that other radios of Browning Drakes in and around the same, 3 or 4 year period used different fonts. Or the people who restored their Browning Drake radios didn't know what fonts to use and just used something that looked nice. I don't know. But this one looked genuine. I don't know, anybody know what Letraset is? Have any of you guys ever used Letraset? It's a rub-on decal. The decals come on a piece of paper, almost like a wax paper, and you press it onto the surface and you rub it, and the decal comes off the paper and goes onto the surface. And that's what I wanted because I didn't know of any other way to do it. But considering that Letraset didn't have anything close to that, and the fonts are totally unknown, what do? Well, you look around the web all over the place and find out that nobody knows anything, is not interested, or it doesn't work, or it's not going to happen. You call Nick Massey, and you say, hey, Nick, what do I do about this Letraset stuff and lettering this thing on the front? And he says, oh, there's a guy in North Vancouver you should talk to. Oh, yeah? North Vancouver. And this is the fellow, Manfred, over in West Van. He has a graphics business, and boy, does he do some spectacular graphics of any sort. So if you ever want graphics done, he's your man. Anyways, I sent him those photos, and he said, well, I don't know what the font is. He says, well, I'll just generate it. I'll just make it. I'll just copy it. And he did, perfectly. He copied all of the fonts, all of those little roundy arrow thingies, the whole thing. 3 days, $150, and that's a little high because I messed up on the font size. And there you go. Just rub them on, all done. Unbelievable. Happy guy. Visit his website. I mentioned I had to get earphones. I had to get the decals. I have to get the earphones. I got those from that plaything in the past. Just a couple things to note that you don't plug in ordinary earphones because there's a current flowing through them, and they have to have a resistance of about 2,000 ohms in the coils. On the back here is where the cord attaches to the two terminals. There's 45 volts on there. That's not really deadly or anything, but if you happen to pick up the earphone like that, you might notice something. These things weren't CSA approved, and UL wasn't around. I tell you, they're damned uncomfortable, and they don't sound any good at all. But there they are. I mean, you got to keep in keeping with this stuff. Speakers. Where am I going to get speakers from the period of 1925-ish? Well, eBay. This is what they call a trumpet speaker. Obviously, it has a big trumpet. It stands on this heavy base. Inside there is a speaker coil. This is unlike modern speakers, of course, but same principle. There's a coil. It activates a pin of some sort, which is connected to a diaphragm down in the base here.
Did it have a DC magnet as well?
Did it have a DC magnet? I couldn't get in to see it without busting something, so I left it alone. Yes. It turns out this was made by a company called Sal. Never heard of them. 1925, $25. I think everything cost $25 back then. No, one cost $22. I paid $190 for that from a vendor in Quebec on eBay, which was actually a really good deal because there's quite a few of these for sale, but they want like $300, $400, $500 for these things. Unbelievable. I said to the vendor, I said to her, does it work? I don't know. I said, well, can you measure the coil resistance to see if it's continuous? I mean, coil could be open circuit, then what do I do? And she says, I don't know what you mean. Okay, so I paid for it on spec, saying I hope this thing works. It actually has the original cloth-covered cord here. I plugged it in and it worked. God, talk about horseshoes where the sun don't shine. So that was good. I got that. And then a friend of mine who's into this business as well, he said, I got an old RCA speaker here, an RCA 100A. Again, turns out right on the money for dating, and brought it down, and I had to put new grill cloth in here and buff up it's a metal case. It's a cast iron case. Weighs a ton. And the grill cloth was all rotted out, but the speaker worked. I mean, how lucky can you get? So I buffed it up and put the new cloth in. Again, eBay, you can get the old-time pattern, colors, eBay. Not much. Get batteries. No, you're not going to get batteries. They don't make these anymore. These are the 1.5 volt dry cells, of which there was 8. These things powered the filaments, to make all the tubes glow, that little red glow. They sucked current like it was going out of style. And these things didn't have much capacity in those days. So they were always dying. I don't know how you could afford to keep the radio running, quite frankly. So you couldn't buy that, nor none of the other batteries. Curiously, I looked for the 45 volt dry cell packs. I found one here. It's dead. It's for display only, but they wanted $45 for that. Oh, yeah. Well, at this point, I've got everything pretty much going in the sense that all the parts are replaced and it looks good. So, Go lithium, no. So I thought, well, all right, let's keep going. So I got to build a power supply because we can't use batteries. This is all that's needed is 135 volts at 10 mils for the speaker amplifier, 90 volts at 10 mils for the first audio and RF tubes, 45 volts for the 10 mils for the second detector, the detector, 800 mils at 6 volt for the tube filaments, minus 3 volts for the grid of the first audio, and minus 6 for the speaker amplifier tube. That's all. You can't buy that. Can't buy it. You have to make it. Grief. Okay. So I made it. It's in a little black box. Kind of packed in there. I kind of misjudged the size of the components in there, and it was a real stuffing job, but it fit in. But it gets a little warm, had to put a fan in. But basically what it is, 2 transformers here. The first transformer off the 115, steps are down to 12 volts. We rectify it, and then I use a regulator in the circuit to give me 6 volts at about 800 mils for all the filaments. I take that plus 6 volts, have a little solid state voltage inverter here that gives me minus 6 volts for grid bias, and regulate that down to minus 3 volts for the other grid bias. All these different tubes require different biases, different voltages. So we did that, and then the other one, of course, is the high voltage. Rectified it, regulated it, and then zenered it down to 90 volts regulated and down to 45 volts regulated. So I got all the plate voltages, plate meaning the 3 high voltages required by the tubes, the grid voltages to bias the grids, and the filaments to warm them all up. I wasn't sure what to do. I kind of went overboard, I'd have to say, because I used regulation to ensure that the ripple and hum was suppressed to just about nothing, because these radios don't have filter capacitors in them. There's no electrolytics. They haven't been invented. So it ran off pure DC, so I had to make sure that I wasn't going to get any hum into this thing just because I didn't bother to filter the rectified DC well enough. So that became a job in itself. So I got it rebuilt. All the components look okay. The power supply worked. The speakers are on hand, and they were working. So, the question is there any chance this thing will actually work? So I had no idea where to set the knobs, so I just set them where I thought they should be. Turned on the power supply. No smoke. Nothing went wrong in that respect, but the radio was absolutely dead. Didn't hear a thing. Not a hiss. Nothing. Oh dear. Well, I looked in the radio and the detector tube wasn't glowing. Oh, God. The filament's gone in it or something. And I don't really have a spare. I don't have a spare. But I looked at the schematic, and I found, curiously, there was a 30 ohm resistor in series with a 35 ohm, one of those rheostats on the front panel. And that seemed odd to me. like that's too much resistance. All the other tubes had just a 25 or 10 ohm rheostat. And this had a 35 ohm rheostat plus another 30 ohms, twice the resistance. So I thought, well, I don't think the tube's going to work under those conditions. So I said, okay, I'll take the resistor out and bypassed it, powered it on, came to life. Holy cow. Well, that was a big moment. It actually worked. There it is. So there's the restoration. I don't think the aspect ratio is, I guess I'm looking at it from the side. But there you can see the cabinet's all been finished. The front panel's all glossied up. All the dials are restored. There's all the logos and everything on it. This is the RCA speaker, and this is the horn speaker. Stereo. Didn't know they had stereo back then, did you? Well, it's just like the earphones, one on each ear. What do you got? Okay, so just as a summary, it took me 3 years from start to finish, but I wasn't working it on continuously, at least not every night. And I guess I sunk about $700 into this thing by the time you add it all up. What do you get out of it? Well, satisfaction, huh? I really was interested in the technology of the day, what they were doing back then in the 20s. And I thought that was really, that interested me. So there's about 12 different appendices attached to this thing. When we post it online, you can go have a look if it's of any interest. So now comes the time to have a look at it and turn it on. Limitations, but don't expect hi-fi. There's no booming levels of audio. It only tunes a part of the AM band from about 540 to 1350. It only takes the 4 controls to tune her up. And it's a back and forth mechanism. This horn speaker sounds tinny. The RCA speaker sounds bassy. And here was the biggest thing. The biggest unknown here is, will this radio work in here? Because here's the problem. This is a realistic radio. That's on the AM band. Nothing works in here. Why is that? I'm going to go over to the windows. Oh, that's for FM. So let's see. If we go over here, it's gone. This building is so well accidentally shielded for our structural integrity that all the steel and metal in this thing just cuts off the AM band. The wavelength is so large it doesn't penetrate the building. So if this modern miracle of super heterodyne, realistic Radio Shack radio can't hear it, how is this thing going to hear anything? So I was a bit worried about that. Oh, Tom, what a thrilling idea. I threw a wire out the window, didn't hear a thing tonight. Yeah, this was, figured out tonight. To make a long story short, there's a piece of coax going off into the radio room, which is connected to, what did it go to? It went to the inverted V, which is about, 120 feet up there. And it receives okay. So I think we'll be all right.
Actually, I think we made sure that it was mistuned for the ATU in line as well.
Oh, yes.
Because our concern was that with the tuning unit, it would have made sure that you weren't going to get the broadcast band. So it was tuned with the loop, and then we just shorted it out and made it into the vertical.
Sort of, yeah.
Yeah.
Okay. So, in case you don't know what this is, it's a trumpet. Whoa. Boy, I can hear everything now. I got to get one of these around the house. All right. So this is the trumpet speaker, which goes into this bass. Very easy. Just fits right in there. There you are. Here's those very best quality earphones of the 20s era. Comfort is no object. Brandy's, or Brandis. Yeah, you've heard of them? Yeah. Says right on here, C. Brandy's Incorporated, New York, Superior. These are Superior. It says so right on them. And then over here we have the RCA speaker. Looks quite nice. It kind of buffed up okay. And of course there's the radio. Yeah. Yeah, it's for sale. $7,000. Other questions? Gordon? Sorry. Gord asked whether this type of radio would be used in the transatlantic, as in Marconi and his...
No, the Armstrong tests.
Oh, the Armstrong tests. I couldn't say for sure. I don't know.
I think Armstrong, those are regenerative radios, and that was the first use of regeneration, I believe, which is why the American radios worked and the British ones didn't.
Yes, Armstrong invented the regeneration circuit. It's in the appendices here, that, and a link to the explanation of how that all worked. Yes. Is this a regen? Well, I guess you'd have to say it is, because that's what that second stage is all about, is regeneration. Detection, amplification, yes. Anybody else?
Yeah, I wanted to ask you a question about the work. Did you do all of the casework, refinishing and stuff like that yourself?
Yeah, the question was, did I do all the work myself? Yes. Yeah.
Including the
Wood, phenolics, electronics, yeah, everything. Any more questions, anybody? We're done? I'll keep working on the radio. Thanks very much.
Yeah. Okay, thanks, John.